I am Neeta Sharma from PM Expert. Today we will build intuition for the cost function in machine learning. The cost function measures how bad our predictions are on average. Lower cost means better model. We start with two ideas. First, loss, the error for one data point. Second, cost, the average loss across all data points. For regression, we often use mean squared error. That's the average of squared vertical errors from the line to each point. Let's write the symbols we will use. Let us see a simple linear regression picture. We will plot a few data points, draw a line prediction, and show the vertical errors. First, the axis. Next, 3 data points. Now, a model line with slope 1 and intercept 0. The vertical red segments are the errors for each point. Squaring those errors makes all contributions positive and penalizes large errors more. For linear regression, we most commonly use mean squared error. That is 1 over n times the sum over I of the squared error, y hat minus y squared. Squaring keeps everything non-negative and gives a bigger penalty to larger errors. Let us compute the cost numerically for our 3 points. Our dataset is left parenthesis 1 comma 2 right parenthesis, left parenthesis 2 comma 3 right parenthesis, and left parenthesis 3 comma 5 right parenthesis. First, with slope 1 and intercept 0. We plug in and get mean squared error equal to 2. Now, let us shift the line up to intercept 1, keeping slope 1 the same. Watch the line move up. The red errors shrink for the first 2 points. Recomputing the cost gives about 0.33. That is smaller, so the second line is better for this data. How do we find the best line automatically? We minimize the cost. A common method is gradient descent. Imagine the cost as a curved bowl as we vary the slope m while keeping b fixed. We move downhill in small steps until we reach the bottom. The update rule is m new equals m old minus alpha times the derivative of j with respect to m. Let us draw cost versus slope for our 3 points while keeping b equal to 1. We will start at slope 0 and take a few steps of gradient descent. To summarize, the loss measures error for one example. The cost averages that loss over all examples. For regression, we often use mean squared error. We search for parameters that minimize the cost, commonly using gradient descent. Lower cost means better predictions.